Hi, my name's Stuart Lynch. WeatherKit provides timely weather information, including current weather conditions and chance of precipitation. It also provides us with hourly and daily forecasts, as well as severe weather alerts. In this series, we'll be building a personal weather application. Now, of course, there are better applications out there, including Apple's own weather application, so why would you want to build your own? Well, if you're creating an application that includes different destinations, like a travel app or one that uses MapKit, you might want to include the ability to check out the weather in those locations either now or get the forecast for the next 24 hours or for the next 10 days. WeatherKit offers valuable weather data for your apps and services to help people stay up to date on the latest conditions. I love getting your feedback, so tap the thumbs up button if you enjoyed this video and leave a comment below. Make sure you subscribe to the video and ring that bell to get notifications of new videos. And if you want to support my work, you can buy me a coffee. So here's the application that we'll be creating, custom icon and all. When the app launches, a custom launch screen is presented, and if this were the first launch, your permission would be asked to use your current location. Once granted, as I've already done in this example, you're presented with your current location's weather. You can see that the time of the recording of this demo, it's Tuesday, February 27th at 10:24 a.m. and it's mostly cloudy and currently 1 degree Celsius, but the expected high is 5. I can swipe through the hourly forecast and see that I expect a drop in temperature and there's a 37 to 50% chance of snow later today. That's strange for Vancouver. I can get a 10-day forecast, and at a glance I can see the projected weather conditions as well as the range of temperatures. So it looks like tomorrow is going to be the warmest, while Sunday the coldest, with no expected precipitation. I can check out other cities, and it looks like I have Chicago in the list right now, and it's 12:24 there, partly cloudy, and a balmy temperature of 20 degrees. Let me check out its forecast. Looks like it's going to be cooling down there. Let me add another city in another part of the world. I can use the search bar to search for and locate, say, Melbourne in the state of Victoria in Australia. It's 5:24 a.m. there, clear and 18 degrees. When I check the weather forecast, I see that although it's February 27th here, and it's a Tuesday, in Melbourne it's a day ahead, and it's Wednesday the 28th. There are a lot of things that you have to pay attention to. If I were in the US and my iPhone region was set that way, the temperature would have shown in Fahrenheit. If I were set for Europe, the date and time formats would be different. All of these things we'll be covering in this 7-part series, so let's get started. Access to WeatherKit is included in the Apple Developer Program, which also provides all the tools, resources, and support you need to develop and distribute apps, including access to beta software, app services, testing tools, app analytics, and more. This means that in order to follow along with this series, you'll have to have a paid Apple developer account. WeatherKit provides up to 500,000 API calls a month per Apple Developer Program membership. If you're going to be creating an application that includes access to WeatherKit, keep this in mind, as once you exceed that threshold, you'll have to pay. So a subscription would be definitely worth considering. You can find out more at the developer website. There's one thing in particular to note, and that's this. When using WeatherKit in your apps, or web apps, or websites, you'll need to follow guidelines and requirements for attributing weather data from Apple. So for details, view this requirements section below. We'll be covering this as well. So let's get started by creating a new application. Create an iOS application and call it whatever you like, but I'm calling mine My Weather. Well, I'd like to restrict my application to be available for iPhone only, so select your target, and then in the Support Destination section, remove All but iPhone. And then in the Deployment Info section, remove All but Portrait. Then with your target still selected, choose Signings and Capabilities. You should have automatically managed signing enabled and the unique bundle identifier will be set. This will automatically create the app ID and certificate that you'll find in your developer account. click the plus capabilities button and search for and add WeatherKit. And then build your app. Then go to the developer.apple.com site and log into your account. Once logged in, go to Certificates, IDs, and Profiles, and then click on Identifiers. Well, you can see that I have a lot of applications that I've developed, so I'm going to do a search for and look for my weather. It finds it, among others, and I can drill down on it. And if I scroll down to the bottom, you'll see that WeatherKit has been checked. Now, the mistake that most people make is to not take the next step. Scroll back to the top and click on App Services. In this section, you must click on the WeatherKit as well. Now, I've already done this as I've used this same bundle ID for my development of this series, so I'm good to go. But what's next for you? Well, for you, you'll have to go have a coffee because it takes at least 30 minutes for this to be activated. And until it's activated, there's no point in continuing on with this series. So I recommend that you pause and come back again in half an hour. Well, now that we're back, we can start working on our project. The first thing that I'm going to do is to create a new service class to act as a manager for all of my WeatherKit interactions. I'm going to be following along with what I assume is best practice as demonstrated by Apple in their sample app. The only difference is that I'll be using different naming conventions. You can download their app and take a look at it. So create a new group and call it Services. Inside there, create a new Swift file and call it WeatherManager. You'll need to import WeatherKit. And since we'll be finding the weather based on the location that we specify, we'll also need access to core location. So import core location as well. And then create a new class called WeatherManager. Now this is going to be a singleton class, so create a static let property called shared. That's an instance of this class. And then create another private property that is called service. That's an instance of Apple's Weather Services class. It's a shared singleton as well. Now, if you option click on Weather Service, you can open Apple's documentation, where you'll be able to discover the kind of things that you want to do. The one that we want is the asynchronous weather function that requires a CL location and includes a weather query, which will be a simple static property specifying whether or not we want the current weather, daily or hourly, etc. And this will be asynchronously returning the forecast specified. Now, if I drill down on that function, I see that the location is a CL location. And I can drill down further on this, including to see the different kinds of queries, which are the static properties. The one that we'll be using today is current. And then I can drill further down on current, and I see it's a weather query of type current weather. So let me drill down on it. And we can check out the properties that we have access to right here. And this includes temperature, conditions, and a host of other things as well. We'll only be using a few of them, but feel free to explore and add more yourself. Back in the WeatherManager class, create a new function called CurrentWeather that has a single argument for location. That's a CL location object. And it's an asynchronous function, and it will return that specific type of weather, which will be the current weather, but it may not exist, so it's optional. And then we can access the current weather then by awaiting a task unit of work that we will detach with a priority of user initiated. And then within the closure of that task, we can get the forecast by trying and awaiting the Weather Services shared singleton's weather function for that location and include the static current weather query and then return it. Now, if we option click on the current weather right now, we see that it is a type which of task current weather optional with a never result type, where the success is that optional current weather and the failure is never. Now, if we want the success value, we'll need to specify value, and then we return it. This construction will basically be the same for our other queries as well. The only thing that will be changing is the type that it gets returned and what static property we'll use to include. So let's request a forecast for your current location. Now in a subsequent video, we'll create a location manager service that'll help us determine our current location. But in order for us to get right into the WeatherKit API right now, we'll be hard coding our current location. So for this, you'll need your current location's coordinate, latitude, and longitude. So I recommend that you just open the Maps app and do a search for your city. And for me, that's North Vancouver. Then you can select it from the list, and when the sheet appears in Maps, tap the three dots, and then simply just copy the coordinates. And I'm going to save them somewhere for reference. I'm just going to put them right here in the content view as a comment for now. And then I'm going to rename content view as ForecastView. I'll import WeatherKit, and I'll import core location here. So within the struct, I'll create an instance of the WeatherManager's shared singleton. Then I'll create another state property that I'll call CurrentWeather that is the optional CurrentWeather object. And while we're fetching the weather, we'll want to present a progress view. So create another property called isLoading and initialize it as false. And then replace the contents of the body with a VStack. And for the first element in the VStack, use an if check to see if isLoading is true. And if so, present a progress view and a text view with the string fetching weather ... Now when this view appears, we'll want to make an asynchronous call to the Weather Manager to execute the fetching of the current weather. So this is an asynchronous instead of an onAppear operation, so we'll create a task. I'm going to change isLoading to true. Notice that the progress view appears automatically in our preview. And then Apple's example creates another detached task here, and make sure that it's executed as a main actor. And then we can update the current weather state variable by awaiting the result of executing the Weather Manager's current weather for function and supply a CL location formed by the latitude and longitude of our home location. So once that task has delivered the payload, we can assign false to isLoading and display our forecast. Well, nothing will appear on our screen, but we now have the current weather, and we can use any of the properties of that object in our view. So create an else statement, and within it, unwrap the current weather with an if-let. Now, eventually we'll be displaying many cities, so I'd like to display first the time. Remember, we are in a VStack, so I'll create two text views. For the first, I'll use a date.now and use formatted to get the string and specify the date abbreviated and time omitted. And then for the second one, just below it, I'm going to reverse this and omit the date and specify a shortened time. Well, one of the properties that current weather has is a symbol name. And that's the name of an SF symbol representing the current weather condition. So we can create an image for that. Well, I can see that it is cloudy in my forecast. I want to use a colored version of that symbol. So if it exists, I'll set the rendering mode to original and then apply a symbol variant of .fill so that those that have a variant will get that applied, and it will be ignored for those symbols that don't. And when I do that, it looks like that my weather symbol has disappeared. And that's because it's white on a light background. So let's fix that. I'm going to apply a font using a system size of 60 and a weight of bold. I'll add some padding, and then I'm going to set a background of a rounded rectangle with a corner radius of 20, and I'm going to apply a fill of a secondary color, but I'll set the opacity to 0.2. Below this, I want to display the temperature, and WeatherKit will provide me the weather temperature in units of the user's current location. Where I am now in Canada, I can see that my temperature is in Celsius. What if my system was set to Fahrenheit? Well, we can use a measurement formatter to display the correct units along with the temperature. Since I'll be displaying the temperature a lot in this view, I'm going to create a formatter as a static property of the weather service. So in WeatherManager, create a new variable called temperature formatter that is a measurement formatter. So we'll construct this first by creating a formatter that is a measurement formatter instance. And then I'm going to apply a number formatter and set the maximum fraction digits to 0. So I won't get any 3.2 degrees or anything like that. They'll all be whole numbers. And then I'm going to return the formatter. Now in the forecast view below the image, I can create a constant called temp and assign to it the result of calling the WeatherManager's temperature formatter string function from the current weather temperature. Next, I'll create a text view with that constant. And then I'll set the font to a title 2. And below that, I'm going to create another text view and use the current weather's condition.description property and set the font to title 3. Now, to test out that this formatter actually works, we're going to change our preview location. So click on the scheme and choose to create a new scheme. Now, if you're in a country that uses Celsius like me, create a scheme for the United States, like myweather-US. Now, if you're in the US, create a new scheme and name your locale as something that uses Celsius. So, for example, Europe. Next, you can choose to edit your scheme and click on the Run. And then in the lower section, choose a region that will be the region. So for me, that's the Americas, and it's the United States. Now, I'm also going to create one more, though, for Europe, and you'll see why in a minute. So I'll create a new one, and then edit the scheme, and this time I'll choose France for my region. So now when I change the scheme to a country that uses a different system, like the United States, I see that the temperature changes to Fahrenheit, but our dates and times are displayed the same way with the month and day and time using the PM, just like we do here in Canada. However, if I switch to Europe, the date format changes to day then month and a 24-hour clock. But I'm back to Celsius. Let me switch back to the default, my home region. And I'm back to Celsius and the North American date format. Formatters are important if you're going to be marketing your application in different countries. Well, we've got one more thing to do, and that's the attribution. In WeatherManager, create a new function and call it Weather Attribution. That'll be an asynchronous function and return an optional weather attribution that we'll get from the API. Well, we can construct this in a similar way that we created the CurrentWeather function. We'll let the attribute be the result of weighting a detached task with a property of user-initiated. Then we can return from that task by trying and awaiting the self.service attribution property. And then we'll need to specify the results value and return that attribution. We can follow then this by creating a new attribution view SwiftUI file. Import WeatherKit. The weather attribution will provide us with an image URL that can be used for either a light or dark background. So create an environment variable for color scheme. And create an instance of the shared WeatherManager. Create a state property for attribution that will be that optional weather attribution. And then replace the body with a VStack. To the VStack, attach a task that will be run once the view is presented, and then create another detached task that can be used to update our attribution property, so specify @MainActor. And then we can update the attribution by awaiting the WeatherManager's weather attribution function. Then within the VStack, use an if-let to unwrap the attribution. And then use an async image with a placeholder. Now the URL will depend on the color scheme. If it's dark, we'll use the attribution combined mark dark URL. Otherwise, the attribution combined mark light URL. Now this async image will give us an image that we can use to create an image view. Make it resizable, scale to fit, and give it a frame with a height of 20. And then while the async image is loading, we can use a progress view as a placeholder. Well, the attribution also has a service name and a legal page URL. So we can use that to provide people with a link to get more information. And I can use Markdown for my text to create the link. And in Markdown, you use square brackets where you provide the actual link, which is the attribution service name. We can do that in string interpolation. And then within regular brackets, again using string interpolation, we can provide the text, which is the attribution legal page URL. And then in the else clause, after the current weather description, present the attribution view. Let me run this in the simulator now. It all looks okay, but when I tap on the link, I get a failed to open URL error in the console. And this is because we're using two variables in our Markdown string. To solve this, we'll need to use the string initializer for our string. Let me test this once more. And now when I tap on the link, I'm taken to Safari and getting that Apple's information. And if I go back to the view, I can switch to dark mode and I can see the difference. Now for each video, I'm going to be saving the completed source code as a new branch in a GitHub repository that you can download. So I'm going to stage and commit my changes now. And then before I push this up to my GitHub repository, I'm going to rename the branch as one_introduction_current_weather. So if you're looking to download the completed source code for this video, make sure you download this branch. A link's in the description. So I hope you have enjoyed the beginning of this series. There's lots more to learn, so make sure that you subscribe to my channel and enable notifications so that you'll know when new videos are released. You can also check out the playlist link above to find all of the videos in the series so far. Now, if you are enjoying this series, please give it a thumbs up and leave me a comment. Thanks for watching.